this is the last part of this notebook, and what we're going to do is to have a Python example. So this is a live spectrogram. Stay here. So we have sampling, downsampling, upsampling, and the effects of low pass filtering. So let's go through this code. So this is some Python imports and some configurations. We're going to use PyAudio again to handle the audio streams, and we're going to use NumPy for Python arrays and some mathematical operations. We're going to use SciPy signal for implementing a filter. We are going to use matplotlib to plot, and we're going to use IPyWidgets for a graphical user interface. Again, we will have a separate thread. In this case, we're going to use the blocking mode of PyAudio. We'll run it into a separate thread, and then we can also interact with the graphical user interface. Here are the parameters. We're going to use the block size 2048 samples. It's mono, so channel equals to 1. This time we're going to use a sampling rate of 32 kilohertz. The downsampling and upsampling rate is a factor of n equals to 8. We are going to use 16-bit integers. We are going to use here for the spectrogram number of FFT points of 1024, and the overlap value for the spectrogram is 512. So here, let's run this the cells. Here we are defining our low pass filter. So this is an II infinite impulse response filter. We are using here the more normalized frequency, so it's 1.9. so it's as the factor is 8, so we are using filter with the cutoff frequency of 2, approximately 2 divided by the Nyquist. So this is what we have here, and I'm just putting 100 Hertz for margin. This is the ripple 60 dB, and we're having a low pass filter. And here are the memory for the filter, and this is just a Boolean variable to turn the filter on and off that we are going to use inside our function, and to control the graphical user interface. We can also control the sampling, so it's this downsampling followed by upsampling to turn on and off. Here we are using just some control for plotting. So it's PyAudio and Python in general not very good to handle real-time audio, especially if you want to process, filter, and also to plot at the same time. So this control here is just to not to plot every time, but to have a certain number of to choose a certain frame rate for plotting. Here we're defining this function called the run spectrogram that will be run inside the thread. So this run spectrogram, we are reading the data stream from PyAudio. This is what we are doing here. Then we are converting this stream into usable data, and we are converting to floats. Here, this is our filter. This is the low pass filter before downsampling. So this is downsampling followed by upsampling. So this is what we are doing here. We are using again the multiplying with the post train using this modulus function, and here is the low pass filtering after upsampling. So this is the combination of downsampling and upsampling, and here we are playing back the filtered and sample version of our signal, and here we are updating the plot. We are calculating a spectrogram, and here we are setting the new values for the initial plot. At this point here we are creating a graphical user interface, so we have a button to start, a button to stop, then a checkbox to turn downsampling and upsampling on and off, and a checkbox to turn the low pass filters both before downsampling and upsampling on and off. So these are the functions that are called when there's an interaction with this button. So this is the start button, will start the thread, and the thread, this function here will run inside this thread. This is to stop. When you stop, we're going to close, to stop the stream, to close, to terminate the PyAudio instance, and also to close the plot. Here we're turning the sampling, downsampling and upsampling on and off. Here we are turning the filters on and off, and here we are creating some boxes to hold the buttons. Here we are defining the thread, and the run spectrogram function will run inside this thread, and also will pass the toggle run as an argument for this function that we want to stop this. There is this infinite loop here. We want to interact with our graphical user interface, and when we press stop, we want to break this loop and stop. Finally, we are creating a PyAudio instance. We are creating and opening our stream, and then we will read the stream and run our example. This is the last part of the code where we'll initialize the plot with some initial values and display the graphical user interface elements. So we're displaying the box we defined before. We're creating here our plot, setting with some initial values, and we also have a close event for when we close this graph, and then it will terminate the stream, terminate PyAudio. So rock and roll, tests, blues, jazz, and funk. Keep up the funk. The rock and roll, yeah. So we have our spectrogram. Now we will turn on downsampling and upsampling. So at this point, there is no low-pass filtering, and we can see the aliasing components when we have the downsampling and upsampling without the filters. Hello, A. But now we turn on the filters. A. Hello. Teste, teste. Som 1, 2. Teste. Ei, teste. Ei, som. Rock and roll. Rock and roll. Rock and roll. Ei, rock and roll. Rock and roll. Som. So we see here that we can reconstruct here at this point. We just reconstruct 1/8 of the spectrum. We would need more filters to reconstruct the full range of frequencies of the signal. Here we just have one low pass, but if we have here a downsampling upsampling rate n equals to 8, we can use 8 different filters, and then we fish out from the aliasing components the frequencies we want, and we end up with all the frequency range, and we can reconstruct the original signal if we have more filters. In this case, we just have a low pass filters, so we just seeing here that we are removing some aliasing components, and we just have here the reconstruction of 1/8 of the original signal. So that's it for this notebook, and see you on the next one.